ISBM, your first step towards right career.
This is notepad. Just like I can give you the example, just like a formula and ax plus what I have told you plus by, ax plus by plus c. This is a simple linear programming formula. Is less than equal to something you can take like a w. This is the example I have told you, but the same example we can write in the form of summation. So what shown over here in the program, in the slide, the same thing shown over here. Then subject to this, where I is equal to from 1 to m and x j is greater than equal to 0, and where j is 1 to n. The decision variable x1, x2, x3 represent the level of n competing activities. See problem. Example problem. There is one problem, a product mix problem. A manufacturer has mixed amount of different resources such as raw material, labor and equipment. These resources can be combined to produce any one of the several different products. The quantity of the ith resources required to produce 1 unit of the jth product is known. The decision maker wishes to produce the combination of product which will maximize the total income. See, there is a two product, and what exactly the I mean to say, I can say the store manager or a store keeper want to maximize the profit. How to maximize the profit to combine these products, and with the help of that, how can we maximize the profit? So over there they have written over here these all the things. Product mix problem, a kind of problem. Second is a blending problem. A blending problem refers to a situation in which number of components or commodities are mixed together to yield one or more products. Typically, different commodities are to be purchased. Each commodity is known as characteristics and cost. The problem is to determine how much of each commodity should be purchased and blended with the rest so that the characteristics of the mixture lie within the specified bounds and the total cost is minimized. Here, if the person want to minimize the cost, in the previous problem they want to maximize the cost, maximize the total income. Here they want to minimize the cost. If I am going to purchase something, raw material, so I want to purchase a raw material. With the help of that we can minimize our cost while purchasing a raw material. That's an example they have written over here. Then product scheduling problem, third kind of problem. A manufacturing knows that must supply a given number of items of certain products each month for next n months. They can be produced either in regular time subject to a maximum each month or in overtime. The cost of producing an item during overtime is greater than the during regular time. The storage cost is associated with each item not sold at the end of the month. The problem is to determine the product schedule that minimizes sum of production and storage cost. See, actually this is something different example. Here they want to maximize the number of the item or product in a certain product of each month. How we can maximize our product? So there is a either we have to run on the regular basis, and or if we have to work on a overtime, then with the help of overtime we can maximize our number of the products. And with sometimes if the number of the products will increase, we don't have a storeroom to store those things. So storage cost is also associated with the number of products when we are going to increase. So not sold, the product which is not sold, obviously they have to stay. They have to keep somewhere in a storage room. So storage cost is also associated with the cost of the product. Next is a kind of problem 4, which is transportation problem, which it's a different. Basically, it's a linear programming, but we have another chapter which we are going to learn in coming days regarding the transportation problem. A product is to be shipped in the amounts of A1 to AM from M shipping or origins. and received amount B1 to Bn at n shipping destinations. There is source and destination from where we are shipping the amount of the product and where we are receiving the amount of the product. It's like A1, A2, A3 up to An we are sending, and B1, B2, Bn we are receiving. So sending and receiving, there is a two. The same thing. Shipping cost is also involved in the transportation problem. The cost of shipping a unit from ith origin to the jth destination is known for all combination of origin and destination. There is two things. While shipping and destination, shipping to the destination, I mean to the sending and receiving, this is a 2 point. So shipping of the ith origin and taking of the jth destination is all combination. The problem is to determine the amount of shipped from each origin to each destination such that the total cost of transportation is minimum. See, actually, what exactly our goal is? Our goal is to sending, I mean to say, a product from one place to another place in such a way that our cost will be minimized. Our transportation cost should be minimum.